Hi, my name is Rscoe. I am pursuing my BTech in Civil Engineering from Jspm'S Rscoe College of Engineering. Our presentation is on AI-based hybrid crop pairing system. The name itself suggests AI-based hybrid crop system. It identifies the characteristics of two plants to give the best pair of the crop for the growth. Next. The problem, trial, error, farming. Current reality. Now I will talk about the current reality. The current reality in this, today in India or worldwide, basically the farmers are not that educated or may be educated, but the majority farmers are not educated. So they crop the plant without any knowledge, without taking any knowledge from others and any sources. So farmers rely on guesswork and traditional knowledge to pair crop. Without data-driven guidance, wrong combination leads to. What does it leads to? Reduced yield and lower productivity, poor nutrition utilization and soil depletion, insufficient water uses and increased fertilizers cost. Next. The solution, data-driven crop pairing. AI engine, location specific, farmers app. I'll talk about both three of them. First, AI engine. In AI engine, it is a kind of engine which has the information about all the crops worldwide. Means it will give the characteristics, information, the pair of the crop which we would have to grow. Next, location specific. Location specific means we can put the location according to us, or there will be the option current location over there which will be recognize our location and it would be incident and based on the location also it would give the information about the crop, does it the best pair of it or not. Next, farmers app. The farmers app, it is an app which will be accessible to all. It would be in our phone and we can access it from our phone itself. It means it would be feasible or would be accessible by everyone.
Hello. So now you have seen we have developed an app to build the hybridization systems. So I will tell you how it works. First of all, we are collecting data for the input process for the soil and soil analysis. We are doing first soil analysis. In that we will gonna add or test some pH meters and organic contents in the crops. Then it will go to analyze the climate data. In that we will analyze the temperature and humidity of the soil. Next, the location factors also matters. Our app or our AI will also detect the location, and based on that location we will going to change that input and or hybrid systems. Next, water availability, the groundwater and irrigation capacity. Next one, AI engine and technology stacks. In this, we are using machine learning model and integrated components of AI, like soil sensor network, satellite imaginary systems, and crop computability data. Or also, in machine learning models, we are using real-time predictions, so we can get better result after hybridizing crops. Okay, next. Here are some examples of crop hybridizations like cotton and moong, sugarcane and onion, and maize and beans. Okay, next. Implementation of I have already said, we are going to collect the data like soil, water sample, and etc. That include in data collections. Then the data will be goes to the cloud for processing. There we are developing AI features so it can be processed accurately to come up better results. Then this all data will go to the farmer. After processing all this data, farmer will get at exact result which they want.
Impact, and just you can see here 20 to 40% of productivity gain and increase land productivity through optimal crop combinations, and 25% of fertilizer reductions, less chemical and input needed with the nitrogen fixing pairs, and 50% of water efficiency, better moisture retention, and reduce irrigation needs only. So next, we will see here benefits beyond yield, soil health improvement, and better nutrition cycling and organic matter building with the complementary crop pairs. Okay, and we will see the cost reduction also, lower fertilizer cost and pesticides and irrigation expenses throughout efficient resources and use. Okay, and we will see here environmental benefits, reduce chemical runoff, improve biodiversity and the sustainable farming practices. Okay, next. Here we will see the last and the steps implementation roadmap. Okay, the phase 1 pilot, deploy sensors on 50 farmers and collect baseline data for 6 months. And phase 2 is the training, train AI models with the collected data, validate recommendations. And the third phase is scale, launch mobile app, expand to 500 farmers in the first year. And the phase 4 is optimization, continuous improvement based on the farmer feedback and yield results.
Our conclusion for this presentation is an AI-based hybrid cropping system that helps the farmer to choose the best combination of the crop to grow together. It uses the data like soil type, weather, water availability to give the smart suggestion. It improves the crop yield, save resources, reduce risk. Overall, it makes the farming more efficient, profitable, sustainable, and in very easy way, and even in very modern way. Thank you.
Thank you.